Um, Good morning, and thanks to all of you for coming here. Before I start on the talk, I want to digress a little bit because I think there was a brilliant presentation by Professor Raghu, and it definitely got me thinking. You know, one of the things I will tell you, and also Subbu explained how Aerospike can help sustainability in a fairly significant way, at least on the IT front. The question I asked myself is, was there even a thought of any of this when we designed it as an engineer, right? The answer is a resounding no. But as engineers, you know, we appreciate well-built systems which do not waste its resources, and they're built well. I'll give you a few examples based on my own, you know, we recently visited the pyramids in Egypt, but that's not the example I was interested in. There is you know, I don't know if many of you know this, but there is a temple that one of the great kings of India built. His name is Rajaraja Choran. Choran is what it's called in Tamil, but he basically built this temple. It's called Periya Koil, or Big Temple, in Tanjavur. Happens to be in the Kaveri Delta, which is the cause of all the problems. But that's completely unrelated. But the point is that temple is built in such a way that the shadow of the Gopuram doesn't fall outside. Why would somebody engineer something like that, right? But that's also, I mean, that's something which I've appreciated before. But what I really appreciated is looking at the Unix source code. It was the first code I ever wrote. It was extremely minimal in terms of the lines of code it was. It didn't use any other resources. It was so well written that I personally have not written any code which is even close to that level of beauty in terms of figuring out. It was basically the scheduler code in Unix. It's what anybody who's a systems programmer should go take a look at it. You know, I definitely fell in love with C because of that. And then the iPhone came out, right? And essentially, the iPhone is, again, another minimal thing. No buttons. You know, Steve Jobs walks around and says, why the heck do you need all these buttons? You know, you just have one button. Now there is no button, which is perfect, right? We all use it and we love it. Aerospike engineers, you know, when we started it, you know, myself and Brian, my co-founder, we also had a minimalist thing because that's what we like to do. We are like, want high performance, and we want to use the resources that hardware provides us to build a system that can take advantage of it. And eventually it led to the things that Subbu talked about, but that level of always efficiently using resources to its maximum advantage is a design principle for good engineering. It doesn't matter what it is. It could be the Ford Model T, the first car. It could be the Tesla. It doesn't matter. Manufacturing, you know, software like Unix, you know, the iPhone, you know, everything that you're working on in terms of Flipkart, Dream11, you know, all of these are systems that are used at scale, and they need to be efficient in order to be, you know, lasting for a long time, okay? And that's important, right? And that's the principle we bring to the table. I just wanted to give that thought to you because it is not by chance that our system is better than others. It was an intent of building it well. And it so happened the side effects of sustainability is really positive for everybody. I'll talk a little bit about why is it that Aerospike is different. You know, it's all great to have a philosophy of building it, but it's also hard to do these things. We focused quite a bit initially on the scaling up. Subbu talked about the hybrid memory architecture, and what that really means is enabling data that is stored in flash to be available for real-time access, both reads and writes. A fundamental problem of traditional databases is that they cannot handle very high write load and at the same time handle read loads with low latency to get the latest data. It's just not an architecture. We changed that with the hybrid memory architecture. I'm not going to go into the technical details here. Grab me later if you don't understand it. I'm happy to, you know, point you to some papers you can read and so on. We even had a recent paper out at BLDB a few weeks ago. We presented it there. It is not, you know, once we put more data in a particular node because we put it in flash, because you can have 10 times more flash storage in a node than you have DRAM. That's not enough. You now need to be able to drive more transactions. Because what happens is when you have 100 nodes then you're running some number of transactions across these nodes. Now, if you put all of the real-time data in 10 nodes, you're going to run 10x the transactions through this small node. And therefore, we focused on the scale-up on processor optimization, NUMA pinning, CPU pinning, multi-threading, and then networking. Because if you can't get the transaction data into the node and out of it, there's a storage parallelization you have to do. There is networking. So we work on all of that, and that essentially provides us a scaling up model where a single node with certain resources can utilize them efficiently to the limit of what the hardware will allow us to do. That is your scale up, and that kind of gives you a huge advantage in terms of the various sustainability and cost reductions, efficiencies we talked about. But that's not enough. There is no database without a distributed system. I mean, it became table stakes about 10 to 12 years ago, or maybe 15 years ago. And that's exactly what scaling out means. The system is written in C, and that requires a lot of, I would say, engineering optimizations. When nodes are removed from the cluster, they come back in, there's a whole bunch of work that has to happen. And we made a very consequential design choice, again, in the focus of minimalism and simplicity, that every Aerospike node, cluster node, is identical. There are no special nodes in our system. That causes a lot more difficult coding for us, but it does make the system survive these situations better in most of the time. We always have rooms to improve, and we keep improving that. And that's a constant thing, okay? The work is not done. That's the other point. And then, because of the optimizations we did in the scaling up and the scaling out components, Aerospike ended up getting a bunch of headroom to develop our own flavor of strong consistency for transactions. So our algorithms are not quorum-based because we don't need to. We can actually write all the copies fast enough. So we end up doing a read one, write all scheme, and this actually, is combined with a roster-based scheme. I won't go into the details again, but the point is, it is a different kind of concurrency algorithm which improves not just performance of the actual transaction, it also improves availability, because we could now make use of the extra performance capability that we had in our nodes to build these algorithms which are which use a few more resources, but provide you more availability, better efficiency, and so on and so forth. All of this, of course, needs to work at scale, and that's what the fourth point is. It's about massive parallelism. We continue to keep working on these parallel abilities, and you'll see some of it in the roadmap today. I'm not going to go through all of this slide because this is too busy, first of all. But more importantly, I want to point out there are areas that we work on, which you will see in the roadmap. Not every area is worked on every year. So it's not like we stopped working on something, but it rotates and comes back. Okay, and you will see that when I take you to the last year and this year's roadmap briefly. From a database point of view, we already talked about the memory storage and the transaction pieces. We also are very focused on making sure our database can run on any environment, on any cloud, on any potential on-prem situation, and so on. Okay, there are obviously certain requirements. It needs to run on Linux. It can run on Graviton as well as Intel now. But the point is that is something we continue to work on. And on the top is the data model place is a huge area we've been focused on for the last couple of years. We now support multiple data models on top of Aerospike. The key value model has been supported forever, documents for almost 5 years, and then there is Graph, and then SQL through Presto, Trino, and so on. So we are able to support multiple models, and we will continue to enhance it with Vector and so on, going forward. We also work with connectors, just so data can move in and out of the Aerospike cluster, but also we can run queries from Elasticsearch or Spark or SQL on Aerospike data. So if you look at what we've been working on for the last year, these are the kinds of areas that we have delivered so far. The Aerospike database 6 started a whole epic, so to speak, of secondary indexes. Changes, we rewrote it, we made them better, more scalable and so on. But also we focused quite a bit on connectors like Elasticsearch as well as SQL Access. Cloud has been a major focus, as I explained to you already, and essentially we added, started working on DBaaS. You'll see some of it. Subbu already talked about how you can start using it as a trial, as well as support for Azure, managed services, and even though Graviton is not a cloud-specific thing, ARM support, but that's where it showed up. In AWS, Graviton is our first ARM port. So we focused quite a bit on cloud over the last year. Additionally, if you look at the developer adoption and developer focus, we've added a team for that, a DevRel team, but also we have started to release and focus on things like the Spring framework, which makes it easier for people to write code on Aerospike. So the way to think about this is you don't have to learn Aerospike APIs, native APIs, to program. If you program on the Spring Data framework, you can just use the Spring framework, and we've written the libraries and mapped onto it. We also implemented Aerospike for LinkPath, so you can actually visualize data in Aerospike, so you can just use that tool. But also, if you look at Graph, what we have built Graph, we built Graph in a two-phase kind of manner. What we have built is a library with not just using the storage, but also having a compute layer in there, which can run the graph algorithm. So you will actually program in the Tinkerpop environment with Gremlin and a tool called G.V and so on. But basically, you will be using programming in Graph, and the Graph data model is translated back and forth using the libraries that our Graph team of experts have done. And these people are Graph experts who wrote this code. And that's so you can rest assured that your application in Graph is well taken care of in this. Okay, so that's kind of I would say a general movement of how features appear on Aerospike. Now let's get to what's actually happening this year. We were originally supposed to have this a few months ago, so this is actually a roadmap which goes up to Q1 of next year. We will revise it again in a few months, and you will see that also. This is the core database, which is kind of the foundation of everything that we have done. And as I pointed out, the 6.x series of releases completed with 6.4. Essentially, the secondary index support in Flash was the last piece that was added. We also added some improvements in terms of the query performance for small amounts of data returns, what we call as short queries, but also improved XDR throughput in various situations, and integration, and the integration with cloud secrets management. Again, security is a huge focus for Aerospike. We keep adding features on that from time to time, and this was one of those things we have added, and it is added in a plugin-based manner. I think we support GCP and Azure now, or we're going to soon support it. But so that's kind of coming along as we go forward. And the good news is we have delinked the core server releases with the plugin releases for Secrets Manager. So you will get more secrets management releases independent of the core server going forward. On the database 7.0, this is our beginning of what I would call as the multi-record transaction epic. We are first redoing the in-memory database option. So originally the data in memory concept, I talked about data being on Flash with hybrid memory, but Aerospike also supports a pure in-memory database system, but the two were not really aligned in terms of how they work, so we're redoing the in-memory piece in preparation for building a robust multi-record transaction system. See, this is one thing you will always see. Again, it goes back to the philosophy I was talking about. It's about making sure that we implement anything that we do efficiently with the same principles that we originally built the product, and we have been carrying it on every feature that we are doing so far, okay? And you should expect that from us, because the moment we don't do that, you might end up getting an MRT system which is not very high performance and then may not want to use it, right? So we are really focused on that. And the in-memory pieces will enable us to essentially support compression, for example, which is supported on Flash namespaces but not on in-memory namespaces and things like that. It'll unify it. We also have the ability to support more bin names, but also more set names. In that release, and that's so essentially we're trying to improve it so you can now model larger and larger database sizes with more and more different types of data on Aerospike. And we talked about 100 petabytes. That's a lot of data. We definitely are multi-petabyte right now, and we are continuing to improve it. Eventually, all of this will culminate in a multi-record transactions release, which will be pretty classic multi-record transactions. The behavior is you open a begin transaction, you run a bunch of things, you change, read, write. At the end of it, you will do a commit, and then that's kind of pretty standard. And that's exactly how this API is going to work. There's a whole bunch of details under the covers to make sure it works well, fast, correctly, and so on, but that's all in progress right now. In terms of enhancing parallelism, we still don't support async I/O. We will be adding that as part of the next series of releases. At some point in the 7.0 series of releases, we will also add things like LRU cache, evictions, and so on. Because LRU cache is a little tough because if you have to actually keep track of data when you read it. A write on a read is not really a good way to do it. So this will be enabled by freeing up some, I'm assuming, some bits in the index, which are basically very difficult to get in Aerospike. If you go talk to, again, the minimalism I talked about is about the size of our index. It's 64 bytes, and it's very hard for bits to come by in terms of store things. But we are finding some because of all the changes we're doing on the in-memory system. So all of this is going to be a really, really good release, a series of 7.0 releases, which will not only be better performing and, as you expect with every release, but also it'll have very important features, which will complete to some extent the Aerospike as a full-fledged database for, again, it's for real time, but it's a full multi-record transaction capability. Clients, I won't spend much time on this. These basically simply track the server releases. We add features to the clients in anticipation of server releases, and there are kind of first-class clients, second-tier clients, and so on. So we just add all these features to clients as you come, and that's basically what all of this is saying. Many of you here have used Aerospike for long periods of time, and quite a few have developed their own tools for managing and running Aerospike in production. I know some customers, I think, at least one of them in this fast life has run like thousands of these nodes and, dozens of clusters, and they built all those tools themselves. Now, we are actually building those ourselves and supporting them. That is basically the big focus of the observability and management group in Aerospike, and that's essentially all about, how do you deal with multiple clusters? How can you drill down? How do you integrate with open telemetry so that you can now have easy integration among all the tools that you're already used to using in your deployments, as well as, some of it is already released in Q2, as well as, there is a whole bunch of new features arriving in terms of from the dashboards for rolling upgrades, dealing with various configurations like all flash, which we don't actually support right now, and so on and so forth. So that is an ongoing process that you will see more appear in 2023 and we're already in 2023, 2024 and beyond. Okay. The operator has been a huge focus. It's actually open source. The code is available, and you can look at it. The important thing I want to say here is multiple large customers are using the Kubernetes operator now at scale in global deployments. These are really large deployments, okay? And we continue to kind of add support for the new Aerospike server releases that come out. Support for 6.4 is out, and then we will support 7.0 when it comes out. And then, Aerospike Connect, these are the connector products. They didn't used to be managed by the Kubernetes operator. Now that will actually start happening later this year. So this is actually a hugely important thing for us because we need to be able to operate all the products that we support, not just the server product. And that's a focus for us. In terms of Graph, I already talked about it. We are focused on Gremlin as a query language right now. We work with G.V. You can actually, this product is out, so you basically can start using it. It's GA. And then the next version, the 2.0 version, will have more observability and management, monitoring, but also support for OpenCipher, which is the Neo4j preferred environment. A few things on Aerospike Cloud. We are now focused a lot on the cloud, as I mentioned already, and Subbu also showed you how you can start the trial. But the idea here is we are designing the system so we can use the same underlying framework, so to speak, and components for both the database as a service component that we will have, but also the managed services. So that is kind of, and we have the control plane, which typically runs on one cloud in the beginning. It's probably going to be AWS. But then the autonomous data plane will run on any of these multiple cloud components. We are targeting, of course, AWS, Azure, and GCP, and in that order, I believe, right now. And that is the way this is going to basically play out over the next year. So in terms of the actual deliverables, an internal beta is already out for a while. And then there's an early access program that is available right away. You can use the URL that Subbu showed to go essentially, sign up for it and use it. And then commercial availability will be later this quarter. So all of this is, in process. And the managed services is kind of aligned with the database as service. And typically what we expect is developers will get started on the DBaaS. And we also have an accompanying DevRel set of items. So it makes it very easy for developers to develop on this particular service and also be able to kind of onboard themselves. They don't have to worry at all about the I would say the managing the system and so on. So no installations required. It's a few clicks, wait for a few minutes, get your cluster, start programming. And we have the ability to, we have a developer hub where you can go get more information on this. And once you've done that, if you're, and you can continue to go, you can go on production in the database as a service setup. But if you get to a really large cluster and so on, we will be able to seamlessly move you over to the cloud enterprise, as we call it. And we are building a lot of, we already have a support for Azure. We are also adding more APIs to make it self-managing on the managed services also. So the difference between the DBaaS and the managed service typically runs on the customer's account, while DBaaS will run on the Aerospike account. Okay, that's one difference. Even though the Aerospike DBaaS isolates data across all customers, so your data is not getting mixed with some other customers. We take care of a lot of security things. We worked with really large customers, run managed services for several years. So we're very aware of the concerns of security and isolation and so on and so forth. Should move? Okay. So finally, right, a lot of the optimizations of Aerospike, we will continue to focus on these optimized implementations for the foreseeable future, because that's kind of our basic calling card or effectively our engineering DNA. And as more and more data and more models are being supported on top of Aerospike, we do expect to fully participate in the AI/ML ecosystem. We already are participating in recommendation engines in various places, in risk analysis, in fraud detection, for years now. But then going forward, I think if one can actually use real-time data in these decision-making and AI processing, I think we will get, a much better decision. Like Professor Raghu talked about, where do you get this information, at what granularity? The more recent data, the more granular the data, so long as it's actually able to deliver you better decisions. All of this is something which Aerospike will play in. We are also working on the vector specifically right now. There was a little demo you saw. It is essentially something we will also work to harden and bring that same level of performance and scale, so that you can benefit from from using it for large-scale AI/ML applications. I think that brings me to the end of the talk.
Questions?
Okay. Any questions?
3 questions. 2 questions.
Oh. I don't see anybody. Oh, there is one.
Yeah. Question.
Yeah, thank you, Srini, for the great talk and insights. One question I have is, I have worked with multiple graph databases like Genus DB, which is a fork of Titan DB, I think, Neo4j. So what is the underlying storage used in Aerospike that enables the organizations to scale up to, terabytes of data? Because what the problem I have faced with Genus DB, it all depends on the underlying storage.
It does.
Whether you are using Cassandra or HBase, what kind of storage you are using, it all depends on that.
Yeah.
So what is the underlying storage?
And that's a great question, because the underlying storage is basically Aerospike for us. So we know that as a key value store, Aerospike is second to none. Now, what we have done is we have implemented graph concepts on our records, on our bins, and various concepts that we have in our data model. We have actually implemented all of that with a database, with a data model for graph to be mapped on the Aerospike data model. And because of the way we can handle things, and all the other things I talked about in the beginning, the high parallelism, the low latency, the high scale, for identity graphs, we are able to map it to terabytes of data and provide a level of performance which is significantly higher than all of these other graph tools. That's what we've seen so far, along with our customers. We are working on more complex graph modeling, and also taking advantage of more, I would say, deeper knowledge of the Aerospike implementation itself to continue to improve our graph implementation. Already it is actually very good, but then we will continue to work on it for more kinds of graphs, and also more deeper integration with Aerospike to kind of get more of those performance advantages and scale advantages we have.
Yeah. So you have this ACMS also, right? Managed
Yes.
Cloud Offering. Like we actually use it. And how is it like? Is it conflicting with your cloud services out here?
Yeah. So maybe I didn't make it very clear, because we changed the name and that probably confused everybody. This is nothing but ACMS. Aerospike Cloud Enterprise is a new name for ACMS. And then if you look at this one, this is basically the entire cloud. It's both DBaaS is also part of it. ACMS is also part of it. We're using the same underlying infrastructure and components, base components, to implement both our database as a service on the Aerospike account. So you can just go click, get a cluster and run on it. Or you can actually use ACMS, which we call as Aerospike Cloud Enterprise.
Okay.
So we continue to support it. The key thing is we did not have DBaaS before. So now when you have DBaaS, how do you seamlessly convert and get to an ACMS if you choose to do that at some scale? And that's kind of why we have to share the underneath the underlying platforms and so on. That's part of all of this.
Yeah.
Okay.
I have a question on the previous slide where an API is being introduced for provisioning. Is that generally available for anybody to invoke and provision it, or is it part of the DBaaS solution?
Yeah, this is for the cloud enterprise. So without going into any confidential information, so we are working with a partner which is kind of a general purpose kind of solution, where they want to run Aerospike services for multiple customers of theirs. So this API will allow you to essentially set up any number of clusters and isolate them from each other. And so, yes, our intention is to make all of this generally available, but it will happen in steps next year. That's all.
Thank you.
Can you do one more, Srini? Just one more.
Sure. I think one of them. And by the way, if you can ask the question now, come find me later.
Yeah.
Happy to.
So you talked about a lot of releases, but you have not touched on the upgrade side, upgrading of all the components. Because you touched on a lot of releases, right? Q1, Q2, new features.
Right.
But not touched on any upgrade, how to do upgrades, all that.
Okay, so the upgrades for us are typically a rolling upgrade for our clusters. And there's obviously a backward compatibility issues between clients and connectors. So we actually manage it, and we try to do as much backward compatibility as possible. And we'll also point out in certain situations where there are what are called jump releases, which I don't believe is any of these jump releases the 7.0s. So so you can actually do rolling upgrades in all of these. That's why I didn't point out anything special. But if there are jump releases, we will let you know. Which means what that means is, when I say jump release, let's say you are on 6.1, and then suddenly a middle release becomes incompatible. We will always have a release which will be compatible on both sides. So you will always have to upgrade through that jump release. That's all it is. But that's not happening here. So you should just be able to upgrade any 6.x to 7.0.
Yeah, one question here. So you guys, like, when are you guys going to come live on Azure cloud? Like, we are already using Aerospike on on-prem cloud.
We are available on Azure now as a managed service, not as a DBaaS. DBaaS is only on AWS right now.
So when is that going to come? Any timeline?
Azure?
Yeah.
As DBaaS or as managed services? As managed services, we are there today.
No, fully pass, I mean to say.
Fully pass. Okay. That will probably be sometime next year.
Okay, fine.
Okay. We are working on that, but it's not, no committed date exists yet.
Okay.
Okay, I've been given a timeout. So you've been given a timeout too. Thank you.
Thank you, Srini. Thank you.
Awesome session.